In this demo I'm going to talk about how the basics of permissions work in the Linux operating system. So that is, who gets permission to read, write and execute files and directories. In this demo I'm initially logged in as my normal user, sgordon. So we see in the command prompt it shows us the name of the user that's currently logged in and executing the shell, in this case sgordon. The prompt also shows us the name of the computer, in this case netlab01 for this demo. And then it shows the current working directory we're in, which is our home directory, which is given by the alias, the tilde character there. So I've set up this computer to have multiple users running on the system. So we'll look at how different users can access other users' files and directories, and how the different permissions impact upon the access. ls of course lists the set of files in our directory, but to see some more information we use ls-l to give a long output. Without going through all the details of the output, if we look at the first line here, we see there are a number of columns. The first column of these 10 characters are to do with the permissions of that file or directory. So we're going to explain what they mean, those D, R, W and X. The other thing that's important, of course, to the rightmost column we have the file or directory name, and each file has an owner in terms of the user and an owner group. So this column here, the third column, shows the owner of that file or directory, the user that's the owner. In this case sgordon is the owner, me. The next column shows the group owner. So we have two different levels so far. We have users and groups, where users can be part of groups, in fact can be part of one primary group and multiple other groups. So a user can be part of many groups in the system. How to set up the users and the groups and the membership of groups is another topic. We won't go through that in this demo. So from the first line we see that there's this file or directory CSS322 owned by the user sgordon and by the group CSS322. And we see in this set of files and directories, there are 8 of them in this current directory, all owned by the user sgordon, me, but they are owned by different groups, CSS322, faculty and ITS413. I've set up these files just for this demo to illustrate some different capabilities we have depending upon the permissions. The thing we want to look at is this first column and what all those different characters mean. And I've summarized that in the permissions file here. There are 10 characters there. The first character indicates whether this is a file or a directory. If the D is there, then it's a directory, and if there's no D there, that is the directory option is not set, you see a dash, then it means it's a file. So we can see in this set of 8 files there are 4 directories and 4 files. In the terminal here it gives us some color-coded output as well. We see the blue ones are the directories, so the directories are color-coded blue in this case. But in some cases you will not see that color coding. So looking at the first character in the permissions, you'll know whether it's a file or a directory. The next 9 characters indicate the permissions that a user, a group and other set of users have on that file or directory. So we can see there's 9 characters and they're separated into groups of 3. So the next 3 characters, RWX, are about the permissions for the owner of that file, the user. So the user for the, in fact the directory is CSS322 is sgordon, as given by the column here, And these three letters, RWX, indicate the permissions that S. Gordon has on that directory. The R means it's readable, W means writable, and X executable. In terms of a directory, you can think of executable as being that you can enter that directory. Readable means you can see the contents of that directory. And writable means that you can modify the contents of that directory. For example, create and delete files in that directory. So in this example, I'm the user S. Gordon, and I can look at the files in the directory CSS322. I have write permissions, so I can edit and create files in that directory, and I can enter that directory because I have execute permissions. That's for the user, the owner of that directory. The next three characters indicate the permissions for the users that are within the group owner. That is, we know that the directory CSS322 is owned by the group also called CSS322. It doesn't have to be the same name there, it just is in this example. We'll see some different ones later. Anyone within that group has the permissions indicated by these three characters, R-X. Again, the characters mean the same as before, readable, writable, or executable. In this example, anyone within the CSS322 group can read the directory. They cannot write to the directory because we see that the middle character there is a dash, that is, the W is not present, so they don't have write permissions. And then the next character, the X, the users in the CSS322 group can execute on the directory CSS322. The final set of three characters indicate the permissions for other users. That is, users on the system that are not part of the group and are not the owner. So that users that are on the system that are not S. Gordon and that are not within the group CSS322. In this example, we see that those other users have no permissions on that directory. They cannot read, write, or execute the directory. And that's the same for all the other files in this directory. If we take the next line, the example.txt file, we know it's a file because the first character is not set to D, it's a dash. It's either a file or a directory. The next three characters, RW- means that the user S. Gordon can read and write that file. They cannot execute the file. Executing a directory means you can enter in that directory. Executing a file means, as you expect, you can run that file if it's an executable program. The next three characters, R-, indicate the permissions for the users within the faculty group. So we see the group owner in this case is faculty. So anyone within that group can read the file, but as opposed to the S. Gordon user, they cannot write that file. Writing the file means editing the file and deleting the file. And then other users on the system that are not S. Gordon and that are not within the faculty group, also have read permissions on that file. They don't have write or execute permissions. So in summary, we can distinguish between a file or a directory using the first character here, the D indicates that this is a directory. The dash, that is the D directory option, is not set, indicates it's a file. Then we classify into the user, the group, and other users, where each set has three different levels of permissions, read, write, or execute. So the characters highlighted indicate the user permissions, where the user is given in the third column of the output of ls-l. The next three characters indicate the group permission, which indicate for all the users within the group indicated by the fourth column in the output, CSS322 as an example, have the permissions indicated by these three characters. And then there are other users, the users that are not the owner and are not within the group have the permissions indicated by the last 3 characters. In this example, they have no permissions. In the next demo, we'll give some examples where different users view and try to execute, read and write to different files. In the previous demo, I introduced the basic permissions that are available in the Linux operating system. That is, we can indicate whether we have a file or a directory, and then whether a user within some group or some other user has read, write or execute permissions. And we can see those permissions in the first column of the output of the ls-l command. I've created some users on my demo system here, a set of users and some files for those users. So let's see what those different users can do and see how the permissions impact upon the capabilities of the users. Currently I'm logged in as S. Gordon. That's my current user, indicated by the prompt here. My current directory is /home/sgordon, and by default every user has a directory in this /home directory. So I've got some files here. In the CSS322 directory, I can enter that directory because I'm the owner of that and I have execute permissions, and I can look at files in that directory. Let's see what I can do in seeing other users' directories. So I'll go into the /home directory and ls, and we see there are a set of other home directories for other users. So this is some example users that have been created on the system, and that's their home directories. So from the user S. Gordon's perspective, we can see that I have permissions, or the permissions given for each of the directories for Bunek, Instructor, Napat and others depends upon what's given in the first column. First, let's see what groups I am part of. Who am I shows my username. That's simple. So I am user S. Gordon. More detailed information of who am I is using my identity. If I run the command ID, I can see that my user ID, UID here, is S. Gordon. In fact, the username is identified by a unique number. So in fact, S. Gordon is really 1003 on the system, user 1003. So that's the user. Also, I have a group ID, my primary group. And in this case, my primary group is set up to be faculty, or group 1007. But a user can be part of multiple groups. So you have a primary group and additional groups. So in this case, I'm set up to be part of the group CSS322, ITS413, and I've also in the as listed here, my primary group, the faculty group. So the user S. Gordon is in 3 groups on the system. To see that in a nicer format, just run groups and you'll see the set of groups that you, the current user, is part of. So let's clear, actually we can go up and let's look and see from the permissions for these other users' directories what I can access. Let's take, for example, this line for Dr. Tanarak's home directory. So Tanarak is another user on the system. We see that the owner of this directory is the user Tanarak, and the group for this directory is faculty. I know I'm part of the faculty group, so we saw that from the groups command that S. Gordon is in the faculty group. So let's look at the permissions that I have on the Tanarak directory. We see here the first 3 characters indicate the permissions for the directory owner, that is the user Tanarak, The next three permissions indicate that for the users of the faculty group. And we see they're all dash. That is, the users of the faculty group have no permissions on the Tanarak directory. That is, I cannot read, write, or execute. Let's test that. I'll see if I can cd into that directory. That is, into Tanarak's home directory. Permission denied. I don't have execute permission on, or the faculty users do not have execute permission on the Tanarak directory. Can I ls? No. So I cannot see inside the Dr. Tanarak's home directory. Even though I'm a member of the faculty group members do not have any permissions on that directory. Also, other users do not have permissions on that directory. So that means I cannot access his home directory. What about other users? Well, we see I can access their directories. The user Bunek, I can cd into that directory. We see, although I'm not part of the students group, I am another user, and we see for the directory here, other users have read and execute permission. So if I try and cd into that directory, yes, I can. And if I run ls, I can see the contents of that directory. So I can access this user's home directory and see files in that. Let's see what some other users can do. I'm going to switch users. Just for the demo, I'm going to log in as a different user. One way to do that is to use the command su, switch user, and then specify the user's name. So I'm going to switch to the user Smith. And just in this demo, I actually know the password. I've created these users and I know their passwords, so I'm going to log in as that user. Normally you need to know the password to access that user's account. I'll cd to the home directory. Now I'm logged in as user Smith, given by the username given here. I'm in the home directory of user Mr. Smith, and who am I? I'm now logged in as Smith. So let's see what Mr. Smith can do in accessing other people's directories. First, what groups is Mr. Smith part of? He's part of the students group and the ITS 413 group. We're currently in /home/Smith. There are no files in his home directory. Let's see if he can access S. Gordon's home directory. Yes. Why? Because if we see the S. Gordon directory owned by user S. Gordon, group faculty, Mr. Smith is in the students and the ITS 413 group. So he's not within the faculty group, he's not the user owner S. Gordon, he's one of the other users, and the permissions for other users is that they can read and execute that directory. That is, they can see the contents of the directory and they can change into the directory, that is, execute. So Mr. Smith is currently in the directory of S. Gordon. He can see the contents of the directory. Can he see the contents of file secrets? Well, we look at the permissions. It's owned by S. Gordon. The permissions for S. Gordon do not matter for Mr. Smith. He's not S. Gordon. The group is faculty. Mr. Smith is not in the faculty group. So from the perspective of the file secrets.txt, Mr. Smith is one of the other users. And the permissions for other users is that there are no permissions. That is, they cannot read, write, or execute on that file. Let's test that. Can we show the output of secrets using cat? No, permissions denied. Can we, as Mr. Smith, delete secrets using rm? It prompts us, do you want to remove a write protected file? Let's try yes. Permission denied still. That is, we cannot delete the file. So we cannot read the file, we cannot delete the file. Can we modify the file? If we open it in a text editor, we see down the bottom that Nano reports permission denied, even if we change something and Control X to try and save and say yes, I cannot save it as that file. So I'll cancel. So Mr. Smith doesn't have permissions to view, edit or execute that file. What else can we do? As Mr. Smith in S. Gordon's home directory, we see another file called print message. We see it's green. Why is it green? Because this file has execute permissions. It's actually a program that we can execute. And again, we look at what other users can do, because from the perspective of this file, Mr. Smith is another user. He has read permissions and execute permissions. How do we execute it? We specify that we're in the current directory, the file or the program name, and I know that how this program works, we supply some message and it should print the message on the screen. So yes, Mr. Smith can execute the program print message. He can also look at the contents of that file. It's just a script in this case, a very simple script that echoes whatever we pass in as an input to the screen. Let's go back into our home directory and see what other users' directories Mr. Smith can access. We see we can execute on the bootneck directory, so cd into that directory as Mr. Smith, and ls-l, see any files in there. So Mr. Smith can access bootneck's directory. Can he see the file myassignment.txt? He can see that the file exists. Can he see the contents of the file? Again, as a reminder, Mr. Smith is part of the group, is a member of the group students and ITS 413. The file myassignment.txt is owned by Mr. Bootneck, and the group owner is students, which Mr. Smith is a member of. But we see the permission for students group members, there are no permissions. So we cannot read the file, permission denied. So we can see the file name, but we cannot see the contents of that file. We can see the file name because the directory /home/bootneck has read and execute permissions for the students users. Let's try another user. I'll switch to a different user, in this case Tanya Torn. Switch user, Tanya Torn, and I know her password, but I typed it wrong. I typed the wrong password in that case. I'll try again. Okay. CD. Its current directory is /home/Tanya Torn. Who am I? I'm now logged in as Miss Tanya Torn, so the user has changed. Let's see what she can access on the system. Let's go into the /home directory and again try to access another user's directory. Let's see what we can access in S. Gordon's directory. We can access, as we seen before. So the user Tanya Torn can access S. Gordon's directory. What groups is Tanya Torn in? She's in the students group and the ITS 413 group. Can she access the directory CSS322? Try. try to CD into CSS322 as Tanyaton, and we find she cannot access because permission is denied. Because for that directory, you need to be part of the CSS322 group to read or execute them on the directory. Miss Tanyaton's only members of the students and ITS413 group, as shown by the output of the groups command. So she cannot access the directory CSS322. But she should be able to access the directory ITS413 because the group owner is group ITS413, which has read and execute permissions on that directory, and Miss Tanyaton is a member of the ITS413 group. So let's try. We can CD in and we can ls. We can see the contents of, we can see the list of files and directories in there, and we can see the contents of the files because again we have read permissions for the members of the ITS413 group, which Tanyaton is. We see there's a subdirectory for students. Let's look at the permissions again. The for students subdirectory has permissions read, write and execute RWX for the users in the ITS413 group, which Tanyaton is. That means of course we can execute and CD into that directory. There's nothing in the directory at the moment. Because we have write permissions on the directory, that is, the members of the ITS413 group have write permissions on this for students directory, it means that they can modify the contents of the directory. Let's try and create a file. Using nano, open a file with it. Put some content in the file and save. Control X, save, yes. Save as tanyaton.txt. ls-l. So in S. Gordon's home directory within the ITS413/4students subdirectory, so a subdirectory in S. Gordon's home, because the permissions are for the group ITS413, they can write to this directory. Anyone within that group can create and modify files in the directory. So we see there Miss Tanyaton just created a file called tanyaton.txt. She is the owner of that file. Her default group is students, and the default permissions created for that file show that others can read, group members can read, and Miss Tanyaton can read and write the file. So we can give other users permissions to create files in other users' directories. Let's try one more example. Let's go back to the home directory, and we're currently logged in as Miss Tanyaton, and let's enter Mr. Napat's directory, which we see student users have read, write and execute permissions as. Other users have just read and execute permissions. Tanyaton is a member of the students group. So we can CD into the directory. We see that there are two files in this directory. With the file, the second file, not so important.txt, it's owned by Mr. Napat, and the group owner is students. Recall, we are logged in as Tanyaton, and her groups include the students group, so she's a member of the group. She has read and write permissions on this file. It means she can edit the file. Open it with nano. It's got some text in it. Add some more text. And let's save the file. Control X. Save changes, yes. Same file name. and just cat that file. So Tanya Torn has changed that file, which is owned by Mr. Napat. She gets permissions to change the file because she's a member of the students group, and members of the students group have write permissions on that file. Write permissions also means you can delete the file. So as Tanya Torn will try and delete the file not so important.txt with rm, and it's gone. So even though the user Mr. Napat created the file, another user had permission to delete the file. What about the remaining file, don't delete this.txt? Can Tanya Torn modify or delete that file? Let's see if we can open it in a text editor. We opened the file with Nano, and Nano reports an error saying we cannot read the file, we have permission denied. Why? Tanya Torn, although they're a member of the students group, we see the permissions. There are no permissions for the student group members to access that file. They cannot read or modify the file. Can we delete the file as Tanya Torn? Yes or no? Gives us a warning, do you really want to remove this write protected file? Let's try yes, I want to delete it. No problem. The file is gone. So Tanya Torn could not view the contents of that file but was able to delete the file. Why is that? Let's go back and check why. The directory, the home directory for Mr. Napat, owner Mr. Napat, group owner students, Tanya Torn was a member of students. The permissions for students were RWX. That is, users who are part of the students group can have the write permission on the directory /home/Napat. Write permission on a directory means that you can change the contents of that directory, including creating files and deleting files. So in this case, Tanya Torn had the permission to delete files into Mr. Napat's directory, even though she couldn't read those files. So that demonstrates some different examples of how permissions can be used. There are much more than what we've covered here. There are some more complex attributes that you can give to permissions, and it becomes complex in how you combine those 9 different conditions, 3 different types of users, the user, the group, and the other users, and the permissions of read, write, and execute. Try and explore to see what you can do on shared operating systems and accessing other people's files, and how you can give other people access to your files. In the previous demos, I introduced the basic concepts of permissions in a Linux operating system and gave some examples illustrating how we can, the different users can access files and directories depending upon the read, write, and execute permissions. In this demo, I want to show the difference between the different types of users. That is, that they're considered normal users and users with administrator privileges, and the commands that we can use to switch between users and elevate our privileges to the administrator user. Firstly, although we've seen it briefly, there's a command called su which allows us to switch users. I'm currently logged in as the user instructor. su allows me to switch to another user. I know on this system there's a user called Smith, su followed by the username, enter. Now it prompts me for the password of Mr. Smith. Now it turns out on this demo I know the password. I type it in, and now I'm logged in as Mr. Smith. If I cd, I'm currently in the home directory of Mr. Smith /home/Smith. So I'm logged in as this user now. So SU allows us to switch between users. If I want to revert back to the previous user, just exit, and now I'm back to being logged in as the instructor user. Of course, this is only useful if you know the password of a different user. In most multi-user operating systems, you do not know another user's password. So how can we get privileges above our normal user status? In many Unix systems, Linux-based systems now, there's the concept of sudo, where it allows an administrator user to execute commands that a normal user cannot. For example, our current user cannot access the directory of Dr. Tanarak because the permissions on that directory, if we try to ls/home/Tanarak, it indicates permission denied. If we look more closely, we see for the directory Tanarak, the permissions for users other than Tanarak, they cannot read, write or execute. So users other than Tanarak cannot view the contents of that directory. Permission denied. Can someone access that directory other than Dr. Tanarak? Well, on a Unix-based system, there's what's called the root user, or the super user, or an administrator user. And this root user has permissions to do anything. They can view, edit and execute any files or directories on the file system. So what we'd like to do is to elevate our privileges for the current user, the instructor, to the root user or the super user. And the common way to do that is to, if you have permissions, use the command sudo superuser do. That is, we want to execute a command, in this case ls/home/Tanarak. Previously we didn't have the permissions to view that directory. We precede this command with the special command sudo, with the idea is that we want to do this command as the super user. And now it prompts for the password of instructor. I'm currently logged in as the user instructor, but sudo is prompting for my password just to check. I'll enter in the password. I am the user instructor. I know their password. And it executes the ls/home/Tanarak command. It simply shows the file. There's only one file in that directory called examples.desktop. What happened there? In the setup of this demo system, the user instructor has administrator privileges. When the operating system was installed, I set the instructor user to be the user with administrator privileges. So when the command sudo executes, it checks whether the instructor user has the right privileges. In this system they are set up that they do have the privileges to be administrator. It prompted for the password, and since the password was entered correctly, it then executes the command, which was ls/home/Tanarak, as the super user on this system, which allows them to see the contents of that directory. So preceding a command with sudo allows us to perform some command with elevated privileges. Normally when you install an Ubuntu Linux based system, the original user you create has the admin privileges, so they can do anything if they precede the command with sudo and enter their password. I can precede any command with sudo. Let's look at another user's directory. There's nothing in that directory, not the best of examples, but note that it doesn't prompt for the password the second time. Since we entered it not long ago, the operating system keeps track that, okay, we've entered that in the last few minutes, we don't have to prompt and enter the password a second time. If we log out and log in, we will be prompted again. So we can switch between users if we know that user's password using su. We can execute any command and with all possible permissions by preceding that command with the special command sudo, and that will work so long as the current user we're logged in as, for example instructor, has been configured to be an administrator user on the system. By default, the group to be in to have administrator access is the admin group, and the instructor user is part of the admin group. If now I want to switch to another user, what I can do is use sudo and su. Sudo to execute as the administrator user, the command su, which is switch user, and followed by the username. I want to switch to user Smith. If I didn't have Mr. Smith's password, but I was an administrator user like the instructor is, I'm not prompted for Smith's password. So I don't need to know his password, because I have sudo privileges. I can immediately switch to the login of Mr. Smith. So an administrator user, also called a root user or a super user, can execute commands if they precede that command with sudo, so long as that user has permissions. In this case, they are part of the admin group. We're logged in as Mr. Smith. Let's try and execute some command. ls, the directory of Dr. Tanarak. So Mr. Smith is executing the command ls/home/Tanarak using the sudo command. This is prompting for Mr. Smith's password. That's sudo's prompting for it. I know Mr. Smith's password. I type it in. I press enter. Mr. Smith does not have permission to execute this command as sudo, and it gives some error message or some warning message saying that they are not in the file that sets up the permissions, the sudoers file, and this incident will be monitored, recorded and reported. So Mr. Smith doesn't have the permissions to execute this command as sudo. In another demo at a later date, I'll demonstrate how to set up sudo and give permissions to different users. So in summary, su to switch between users if we know the user's password. If we're an administrator user, then we can precede a command with sudo, and that allows us to do anything irrespective of the permissions on that file or directory. We've seen the basics of permissions in a Unix-based operating system in a previous demo, where we saw that files and directories have read, write and execute permissions, and those permissions can be set for the user owner, the group owner, or other users. And we've seen that we can switch between users using su and execute programs as the administrator user or the root user using sudo. Now let's see how we can change permissions on files, including changing the owner and group of a file. I'm currently logged in as the user S. Gordon. If I look at the contents of my directory, set of files and directories, let's focus on the file example.txt. I'll just clear and show again example.txt. The permissions for the user owner, which is S. Gordon, the current user I'm logged in as, are read the file, write the file, but not execute permissions. The permissions for members of the faculty group are read, but no write or execute permissions. For other users, there are no permissions. How do we change the permissions on this file? we use the program chmod, where we specify for what set of users we want to change the permissions for. They can be for the current user owner, the group owner, other users, or for all users. And we specify what we want to do. We want to add a permission or revoke or minus a permission, and what specific permission we want to apply, read, write, or execute. For example, let's say I want to add the permission for other users to read the file example.txt. Currently, other users have no permissions. I want to add the read permission for other users. So in chmod, for other users, I'll use O, add the permission, plus read permissions R, followed by the file name, and now let's look and check. We see we've gone from no permissions for the file. We added the read permission for other users, which is indicated now that other users can read this file. And we can use different combinations of the read, write, execute permissions, of adding and revoking permissions, plus and minus, for users, groups, other users, and all users. Let's try some more examples. Let's add write permissions to the file for members of the faculty group. So the group owner is the faculty group, currently has read permissions only. Let's add write permissions by specifying we want to modify them for the group, G, plus add the permissions, W for write. On our file example.txt, let's check the permissions. We see now for the group user we have write permissions. We can subtract those permissions. Let's subtract or revoke the permissions that I just gave to the group users, the write permissions, and also revoke the write permissions for the group users, and let's also revoke the read permissions. So the group users can no longer read nor write the file example.txt, and at the same time let's revoke the read permissions for other users. So we can combine different commands using the comma here. For other users, let's revoke, so subtract the read permissions on the file example.txt. And let's check. We have now, for the group user, they have no permissions. Previously they had read and write permissions, but we revoked the read and write permissions. And other users have no permissions. Previously they had read permissions. We revoked the read permission using the O minus R. So we can combine multiple permissions or permission operations for different sets of users. And another example, we can add execute permissions. In this case, let's add them for the user owner, for S. Gordon, using U to specify the owner, the user, add execute permissions, X, for example.txt, ls-l example.txt. We now see that the user S. Gordon, indicated by, because we used the minus the U option, the user S. Gordon now has execute permissions because we've added those execute permissions for the user owner using the chmod command. So we can add, we can modify the permissions based on the user, the group, or other users. We can also modify the permissions for all users using the A to indicate all users. In this case, I want to set all users so that they can read the file. Just before I do that, just one thing to note on this Linux terminal: when a file has execute permissions, as we added for the example.txt, it's shown in green in the file name list. That's not always the case, just in this terminal. Coming back, we want to add read permissions for all users. A for all users, plus to add permissions, R for read permissions on example.txt. Let's check. And the user owner has read permissions. They previously had read permissions. We've added read permissions for all users, so it simply doesn't modify. They still have read permissions. So S. Gordon has read permissions. The group members have read permissions, and other users also have read permissions. So change mod allows us to change the permissions on files, and we can also do that on directories. And it can be quite complex in the combinations you can have. You need to be careful that you set the permissions to achieve the security goals that you're looking for on your system. It's not so obvious sometimes, and in fact there are many more options that we will not go through in this demo. Let's clear the screen, and now let's look at changing the owner of a file and changing the group owner of a file. Our file example.txt is owned by the user S. Gordon, and the group owner, or the primary group associated with this file, is the faculty group. First, let's change the group owner for this file. The command chgrp, change group. Specify the group that we want to change it to. In this case, I know that there's a group ITS413, and the file name. Change the group of the file example.txt to ITS413. Let's look and check. We see now that the group owner is ITS413. So very simple to change the group for a file. What about changing the owner? Well, we need to be careful there that we need to have the right permissions to change the owner of a file. I'm going to switch to the instructor user for this demo, because I know that the instructor user has administrator access on this system. I know their password. That is, as the instructor user, I can execute commands using sudo. Let's look at the files. I'm logged in now as the instructor user. I switch to the instructor user using su. I'm still in the directory of /home/sgordon, still looking at the example.txt file. The owner is S. Gordon. The group owner is ITS413. Let's change the owner to someone else. And because I'm not the owner, I will proceed this with sudo, because I need administrator access or root privileges to perform this operation. So sudo, and to change an owner, use chown, change owner. Specify the new owner. It's currently owned by S. Gordon. Let's change it to be owned by a different user, Smith. Specify the username and the file. I'm prompted for the password for the instructor user to execute this command as sudo. I know the password for the instructor user. The command executes. Let's check. We now see the owner for example.txt is the user Smith. So we can change groups using chgrp, change group. We can change the owner, the user owner of a file using chown, change own. But we need to be careful that we don't always have permissions to change the owner, and in some cases also the group owner of a file. In this example I used sudo because I knew I didn't have permissions to change the owner to Mr. Smith in this case. In fact, it turns out you can use the command chown to change both the owner and the group. So we don't need to use change group. We can combine, and let's change the owner of the file example.txt back to S. Gordon, from Smith back to S. Gordon, and let's change the group back to faculty. Currently owned by Smith, group ITS 413. I want to change it back to the original, which was S. Gordon, group, faculty. And we can do all that with one command using chown. S. Gordon, and we specify the group followed by a dot. Sorry, followed by a colon. And the group that we want. So now I'm changing two things, the user owner and the group owner for this file. chown, the user I want to change the owner to, and the group I want to change the file ownership to, separated by the colon. And now we see that we have back to our original user S. Gordon and the original group faculty. So we don't actually need to use change group, we can use change own to do the group as well. Look in the man page for those commands to see the different options they have and the different ways that you can combine the user and the group in chown. So in summary, we can change permissions on files and directories using chmod, change modifications. We can change the owner using chown, and we can change the group using chgrp, or we in fact can do it with chown as well. In previous demos we've seen how permissions work in a Linux operating system. In this demo we're going to look at how the users are created on a multi-user operating system in Linux. How do we create users, delete users, and where the information about the users are stored. I'm currently logged in as the instructor user, which has administrator access on this computer. They have sudo privileges, means they can execute any command if I proceed it with sudo. In previous demos we've seen there are a set of users and their home directories are under the /home directory. The user S. Gordon, Nupat, Mr. Smith, and so on. How are those users created, or how could we create a new user on the command line? We'll see how that works. But first, where is the information about these users stored? In the /etc directory there are several files that store information about the username, their login details, home directory, and password. The first file, which we'll take a look at, is in the etc directory, and it's called passwd, short for password. If I run cat to look at the contents, we see each line has a user and some details about that user. Many of these users have been automatically created by the operating system when it was installed, the first set here. But towards the bottom we can see some of the users that we recognized from before. S. Gordon is one user, there's the username, and the other users that have been created on this example system. Just to hide some of the details, let's look at, I'll just clear the screen and look at just one of those users. So grep, searching for S. Gordon, so I just show one line of this file, the one that contains S. Gordon. And let's look at the basic structure of this line. So there are fields separated by colons, where the first field is the username. So username S. Gordon. The second field contains an X. That's to indicate that the password for that user is not stored in this file, but is stored in a different file, the shadow file that we'll see in the next file we look at. Next two fields are numbers indicating the user number, user ID, and the group number for that user. And then there's some information about the user, including their full name, and some information that you can set about the user, including their office number, their work and home telephone numbers, and some other details. So that's what these four values here, they're just when I created the user S. Gordon in this demo system, gave these dummy values, for example 1, 2, 3, 4. We'll see shortly how we edit those values when we create a user. The next field is the home directory of the user, /home/S. Gordon. By default, when we create a user, the home directory will be their username in the /home directory. The final field is the shell that's used by the user when they log in. So in this case, the bash shell is used. So this is the program that interprets all your commands on the command line. So it provides the syntax for all the different things I can do on the command line. There are different shells. Bash is the default shell that's used in the Ubuntu Linux operating system. So that's about the user, S. Gordon. So when I log in, I supply my username, and I also supply the password, and the operating system checks whether my username and password match what's stored here. Well, we can see this, the username stored here, but where is the password? It's stored in a different file for security reasons. The file is called shadow, also in the etc directory, but a normal user doesn't have permission to access that because it stores some information about the passwords for all users. As I'm a sudo user, I can view that file. I need to supply my password to view the file. And it's a file which contains information for each of the users that we saw in the passwd file, and information about some of their passwords. Again, so we can see the instructor user, S. Gordon, and some of our other users, as well as some of those users which were created by the operating system. They don't have passwords, that is, they don't have a password to log on, and that's why we see a star here. Let's again clear and look at just one of those entries. Sudo grep for S. Gordon, and look at the structure of that entry. Again, our fields are separated by colons. The first field is the username, so that must match the one in the passwd file. The next field, which is this long random looking set of characters that goes up to here, is information about the password. And it's separated into three subfields, and we see them separated by $signs. The first value here, the number 6, indicates the algorithm used to store the password. So rather than storing the actual password in the file, we normally apply a hash of that password and store just the hash value. Then when someone tries to log in, they supply a hash of their password, and it compares against the hash value stored in this shadow file, and if they match, then the assumption is that the passwords match. And that's typically true if you have good hash algorithms. The number 6 here indicates what hash algorithm is used, and the number 6 represents the hash algorithm SHA, the secure hash algorithm. Other algorithms can be used, but SHA algorithms is considered secure and is used by default in a Linux operating system. The next value here related to the password is what's called a salt. This random set of characters here. This is a value that's added to the password, so that a random value added to the password for some extra security precautions. One is that if two users with the same password have their data stored in the shadow file, that if we don't use a salt, then the hash values of that same password will be the same. So if S. Gordon and Tanarak had the same password, just by luck, then if we didn't have a salt value, then that hash value will be the same in both files. So if S. Gordon could see the shadow file, then he would also see that Dr. Tanarak has the same password as him. Another reason for using the salt, and it's quite useful, is to stop people who have access to the shadow file for looking up and finding the password based on the hash value by using large tables of pre-computed hash values, rainbow tables for example. The next field is the hash value itself. So the first field was the hash algorithm used, and then the salt, and then this long random string is the hash value from taking the password of the user, S. Gordon, concatenating with the salt value and taking the hash of that. The hash value is stored here. The remaining fields are to do with information about the duration of which the password and the login account can be used. Things like expiring the password after so many days. That's the last set of fields here. Rather than explaining now, to find out more about what those exact fields are, then you can look in the man page for the shadow file. Man shadow will explain those fields. The login name, encrypted password, which refers us to the program crypt to do the hashing, and those other fields about the password, age, and so on. If we man crypt, look at the man page, it talks about the format of the hash value that's stored. And if we scroll down, we see that the format that we saw has the ID of the algorithm used, where the ID is 1, 2A, 5 or 6. We saw 6, which means SHA-512 was used as the hash algorithm. The salt value, and then the encrypted or the hashed password combined with the salt value. So that provides an explanation of how that works and how the algorithms are selected. So the passwd file stores the user details, the shadow file stores the password information, or at least a hash of the password. Another file is the list of groups, /etc group. As we know, we have groups and users can be parts of groups. We see down the bottom that we have the CSS322 group and the group ID 1001. There is no password for that group. The X refers to the group shadow file. We could potentially have a password for a group, and the set of users that are in that group. So how do we add and manage users on a Linux operating system? We could manually set those files, but it's much more convenient to use some programs that are provided to do it for us. And there's add user and delete user, or del user. Let's have a look and see how they work. To add and delete users, we need to have administrator access, so we proceed the commands with sudo. Let's add a user, and the program we'll use is simply called add user. and give a username. Let's add the user Lalita. That's the username of the new user, and it creates the user, and the group for the user by default the same as the username, creates the home directory, and then prompts for the password for this user. I can supply and select a password. We need to type it in twice to make sure we don't make a mistake. Then we are prompted to provide some information about that user, like their full name and the room number, phone number, which I'm just using some example values, and other details. Check if this is correct. Yes. Then after we press enter, then this user has been created, the home directory has been created, and those entries inside those 3 files should be created. Let's check that the home directory is there. Lalita is the directory that's been created for our new user. And let's check in for the username in the /etc/passwd file. We see there's now a new entry for Lalita, the user ID, the group ID, that information about the name and those phone numbers, home directory, and by default the bash shell is used. Similar in the password, in the shadow file. We see that using the SHA-5112 hash algorithm, ID 6, a salt has been created, and the password that I entered in combined with that salt have been hashed, and the hash value is stored here. And finally, let's just check the groups in the /etc group file. We see there's a new group called Lalita. How do we know that Lalita is part of it? Because in this group file it shows that there are no users in this group Lalita. The group ID 1006 in the passwd file indicates that Lalita's home group is the group Lalita. That's clear. Another thing we can do is add a group using the add group command, and let's add a group ITS332. A new group is added. Let's just check. In the /etc group file, the ITS332 group is added, and there are no users of that group yet. Now let's add another user, but add them to the group ITS332 to be their home group. So we use the add user command again, and there are many options available. One of them is the in-group option. Instead of adding this user to their own group, that is based on their username, I'll add them directly into the group ITS332, the one we just created. And let's create the user Chanakan. So add the user called Chanakan, where their home or primary group will be ITS332. Set a password, name, and other details. So let's just look in the home directories and see what we can see. We see the home directory is for our two new users, Lalita, and it's owned by the user Lalita and the group Lalita. And our second new user, Chanakan, owned by the user Chanakan and the group ITS332. That was set using the in-group option when we add user. Another thing we can do is add users to a particular group using the add user command as well. And we simply give the username and the group that we want to add them to. So in this case, add the user Lalita to the group ITS332. And if we can check in the groups file, we see now the user Lalita is a member of the ITS332 group and is also still a member of her primary group, which is Lalita. There are many different options available with add user. The man page gives detailed description of all the options and how add user, add group can be used. To add users, to modify user details, and to add groups. Final thing, let's remove some users. We delete some users using the del user command. Simply supply the username. I want to delete or remove the user Lalita, the one we've just created, and removes the user. Gives a warning that the group Lalita no longer has any members and that group has been removed as well. Note that without any options, the home directory of that user is not deleted, so the directory /home/Lalita still exists. We can delete a user using the remove home option and then the username, Chanakan in this case, which will also delete their home directory. So the directory Chanakan, which existed before, has been deleted because we used the remove home option on when we deleted the user Chanakan. And let's just check in the files, in the past WD file. Although we've shown all, we do not see at the bottom the two new users that we've created, Lalita and Chanakan, because we've deleted them. So those users no longer exist on the system. It's clear. Have another look at the group file. One final thing we can do is remove users from a particular group. Rather than removing the users from the system, we see in the group CSS322 there are three members, S. Gordon, Bunek and Napat. Let's delete one of those users from the group. The user Napat from the group CSS322. So we didn't remove the user, we removed the user from the group. So in the CSS322 group we only have two users now. Mr. Napat still has an account. We have not removed that user. Let's just check. And he still exists on the system. So in summary, we can view information about the users in the /etc directory under pass.wd, group and shadow file, and we can add and delete users as well as groups using the commands add user, add group, del user, and many of the different options available via them. In some of the previous demos we've seen on permissions, we've seen the use of sudo, where when a user doesn't have permission to perform some command, if they precede that command with the sudo special command, then they can elevate their permissions to the root user and therefore execute the command. Of course, not any user can do this. We're going to look at how sudo works and how we can set up so particular users on a Linux system can use sudo to execute selected commands. As a reminder how sudo works, I'm currently logged in as the instructor user. If I want to access a particular file, which I know from past use is not accessible, that is, I cannot access the directory home Tanarak because I do not have permissions to read that directory. If I proceed the command with sudo, with the idea of elevating my permissions to the root user who does have access to that directory, I should be able to see the contents. Sudo prompts for my password, which I know, and in this case, because the instructor user has been set up to have these sudo permissions, they can view the contents of the home Tanarak directory. But which users can use sudo? By default, when you install a Ubuntu Linux operating system, the first user you create is in what's called the admin group, and the users in the admin group can use sudo to escalate their privileges from the normal user to a root user and perform any command and access any file on the system. If you have more than just the initial user on the system, then you need to configure the system to allow those other users to use sudo, and we'll show you how. In this system, the instructor user was the first user created and can use sudo. If we switch to a different user, in this case Smith, and I know Smith's password, now I'm logged in as Smith. If we try and view the home Tanarak directory, we have permission denied, we cannot see the contents. If we try to use sudo to view the directory, sudo prompts for the password for Smith and reports an error saying that the user Smith is not in the sudoers file, not in the special file that configures which users can use sudo and which cannot. And this is a security incident that should be reported. So we need to look at that sudoers file to see how to set up the system to allow different users to use sudo. I'll exit back to the instructor user and let's open the sudoers file, and it's in the etc directory. To open it, you need to be a root user and therefore use sudo, and it's a text file, but we shouldn't open it with a normal text editor. The problem is that if we make a mistake in this file, we use the wrong syntax or provide the wrong command, then we can lock users out of the system and potentially lock all users out of the system. That is, we cannot execute sudo. So we use a special program, sudo, which opens a text editor, but once you edit the sudoers file, it does a check whether it's correct or not. Use -F option to specify the file to open, and the file is in the /etc directory and called sudoers. This opens this sudoers file, the configuration file for sudo, in a default text editor, in my case Nano. The syntax and the options that are available in this configuration file are quite complex, and I'm not going to try to explain how they work. I'll just show some very basic configuration directives that are in the default file. Every line starting with a hash is just a comment. The first line that we'll explain is this one starting with root. The root user on a system should be able to execute any command, and this command says that the root user, if they use sudo, then on all machines they can execute all commands as any user or all users available. That is, the root user can use sudo to do anything. So if you're logged in as the root user, you can proceed any command with sudo and you'll have permissions to execute that command. The next line of interest is this %sudo line. The % indicates it's referring to a group. In the previous case, the privilege specification was set for a particular user, the root user. When we use a %, we refer to a group on the system. So anyone within the sudo group has the capability to execute all commands on the system. Again, in the same privileges as the root user. So if you are the root user, you can execute any command using sudo, and if you're in the sudo group, you can also execute any command using sudo. This include directory directive indicates that we can add extra configuration directories either in the file that we're editing now, the sudoers file, or in separate files under the sudoers.d directory. I'll show you an example of that shortly. The last directive here is similar to the sudo group directive. Anyone within the admin group can execute all commands. So if you're in the admin group or the sudo group, or you are the root user, you can use sudo to execute any commands on this Ubuntu Linux system. And by default, when you install Ubuntu, the first user you create is added to the admin group. Let's check that. So I'll exit, Control X, and if we look in the admin group, which is in the groups, and group members are in the etc group file. I'll search for admin. We see the admin group contains the instructor user. So that's why the instructor user on this system can execute the any commands using sudo. Let's add a user to the admin group. To add a user to a group, again, we need to use sudo. I'm currently logged in as the instructor user. Add user, the username. Let's add Mr. Smith to the admin group and the group name. So user Smith was added to the admin group. Let's just check that. So now Smith is in the admin group. And now let's switch to the user Smith, enter the password. Previously we saw that Smith could not view the contents of home /Tanaruk using sudo. Let's try again. Sudo ls/home/Tanaruk. Prompts for Smith's password. And now user Smith can view the contents of Tanaruk's directory. That is, they can execute the command using sudo because they've been added to the admin group. So quite simply, if you want someone to be able to use sudo to gain root privileges on your system, add them to the admin group. I can remove a user from the admin group using the del user command, so that Smith is no longer in the admin group. and just check that. The admin group is back to the original setup where only the instructor user is in it. So the basics of sudo so far is that if you're the root user, in the sudo group or in the admin group, you can execute any command on the system by preceding it with sudo, and you effectively elevate yourself to the root user, the privileges of the root user. The configuration file that specifies which groups can configure which commands is in the etc directory, and it's called sudoers. In some cases, we don't want to allow a user to be able to elevate their privileges to the root user and do anything on the system. We would like to, in some cases, allow some users just to run some privileged commands. For example, if we want to set up the system so that the student users can execute networking commands, but not view the directories of others, not add users, not do all the other management of the system, then we can configure sudo to do that. I've already created an example extra set of configuration directories for sudo, and I'll show you that using first, before I show you the example, let's switch to a user napat, enter the password. A number of networking commands on the system by default require root privileges. For example, to execute TCP dump, to capture traffic on the computer, TCP dump -i ETH0. User napat does not have permission to capture on the ETH0, the Ethernet interface. You need to be a root user to run TCP dump. And can napat execute TCP dump using sudo? Let's try. Sudo prompts for his password and gives the error message saying he's not configured or in the sudoers file and is not allowed to run this command as sudo. So how can we configure so that individual users or a select group of users can run a selection of commands as sudo? Let's open the file that I've already created to configure to allow some users to run networking commands. I've created it in this sudoers directory, and I've simply called the file student. So I'm going to open this file, which is a set of sudo directives using the sudo command. And it's important not to use a normal text editor here. Again, if you make mistakes in the syntax, then you may lock users out of the system. And in fact, on 2 occasions I've locked out all users from a system and had to go through special steps to recover the root password. Very inconvenient. I've made a mistake. I need to switch back to the instructor user. Of course, napat is not allowed to execute this command as sudo. I need to exit, and I'm now back as the instructor user who can execute commands as sudo. Open this student file, which gives some extra sudo configuration directives. I want to allow a set of users, in particular the users in the net admin group, to run a set of commands as sudo, and those commands are related to networking. So let's just look at the line that specifies what group can execute what commands. This line highlighted indicates that anyone in the net admin group can run the commands specified by netall. Netall is an alias, and you will see in the preceding lines I've created this alias. So any commands that match within the alias netall can be executed by users in the netadmin group. What is in netall? We see the preceding line. I've created a command alias where netall equals or includes all those commands in the network alias, in the capture alias, in the aircrack alias, and a number of other aliases. And in fact, those aliases are defined in the preceding lines. We see that the capture alias is defined here. The capture alias refers to a specific command, TCP dump, and we need to give the full path here. So capture will be replaced with /user/sbin/tcp dump, which is the location of the TCP dump program. Similar, network includes the command ifconfig, ifdown, and a number of other interface configuration commands. WLAN includes commands for configuring wireless interface in Linux, iwconfig for example. So I've just created these aliases just to separate out the separate set of commands. You don't need to use them. Alternatively, instead of using netall, I could have listed all the individual commands here on one line, where I separate each command by a comma. So again, any user in the netadmin group can execute the commands specified in the set of aliases under netall, the network, capture, aircrack, WLAN, and so on, which is really just a list of the actual commands that I want to allow that user to execute. So you can add other commands, you can set up different aliases, different groups to specify what selection of users can execute which commands as the root user. Let's see how it works. I'll Control X. I don't need to change this. Let's look at the netadmin group. There's currently no user in the netadmin group. Let's add the user napat to the netadmin group. Previously, the user napat could not execute TCP dump, even using sudo. They didn't have the permissions. Now we add napat to the netadmin group. Let's just check. And now let's switch to user napat. We're now logged in as napat, and let's use sudo to execute TCP dump. Sudo prompts for his password. I've made a mistake in the command. I used -eth0 instead of just eth0. Let's try again. And now user napat can execute TCP dump. TCP dump is running and capturing packets. So we can set any user to execute the networking commands listed in that sudo configuration file if they're in the netadmin group. And let's just check finally whether napat can execute other commands as sudo, ls, the directory of home of user Tanarak, sudo ls /home/Tanarak. Not allowed to execute this command. So because the command ls is not in that list that I set up in the configuration file, user napat is not allowed to execute that as sudo. He can only execute the commands that I specified. So that's a way of allowing specific users to execute a selection of commands on the system, depending on what you want them to do. Of course, it's up to the manager of the system to select the commands and consider whether the selection of commands meets the security requirements of the system. In summary, The configuration of sudo is set up in the /etc/sudoers file, although other files can be added under the /etc/sudoers.d directory. They specify which users and which group members can execute which commands, and if a user has those privileges, then they can proceed a command with sudo to escalate their privileges so that they can execute a command that they would normally not be able to.